There is a color you can see right now that your ancestors almost certainly could not. Not because their eyes were different, not because the world looked different, but because the word didn't exist. And without the word, neither did the color. This sounds impossible. You're looking at the sky right now, or a screen, or water, and blue is just there, obvious, undeniable. How could anyone not see it? But that question assumes that seeing and perceiving are the same thing. They're not. And the story of how humans stopped noticing blue, then rediscovered it, then invented a word for it, is one of the strangest puzzles in the history of human consciousness. Let's start with a man named William Gladstone. You might know him as a British Prime Minister. In the 1850s, he was also an obsessive scholar of Homer, the ancient Greek poet who wrote the Iliad and the Odyssey. Gladstone spent years reading every word Homer ever wrote, cataloging every reference to color. And when he finished, he found something that disturbed him deeply. Homer described the sea as wine-dark. He described sheep as wine-dark. He described iron as violet. He called honey green. He used a single word, chloros, to describe things as varied as fresh wood, honey, sand, and the human face in fear. He described the sky constantly, endlessly, in image after image. But he never once called it blue. Not once. Across 2 epic poems totaling almost 28,000 lines. The sky in Homer is never blue. Gladstone kept looking. He searched all of ancient Greek literature, the texts that survived, which were substantial. He found that the Greek language had no standard word for blue at all. There were approximate words, borrowed comparisons, but nothing clean and direct like the word we use. For the color that covers more of the Earth's surface than any other, ancient Greek had no dedicated name. He thought maybe this was a Greek problem. Maybe Homer was just one poet with strange habits. So he looked at other ancient texts. Sanskrit, the ancient language of India, one of the oldest written languages on Earth. Almost no mention of blue. The Vedas, one of the oldest collections of religious literature in the world, contain thousands of references to color. Blue is essentially absent. He looked at ancient Chinese texts, ancient Hebrew, the Icelandic sagas, ancient Arabic. In the ancient world, across completely separate cultures that never contacted each other, blue as a named, distinct color is almost nowhere. Every ancient language, researchers found, followed the same sequence. First black and white, then red, then yellow or green, then blue. Always last. Every time. This became known as the Berlin and K theory, named after 2 researchers who in 1969 studied color naming across 100 languages and found the same pattern everywhere. Blue always comes last. But why? There are a few competing ideas, and the real answer is probably a mix of them all. The first idea is simply rarity. Blue is genuinely uncommon in the natural world. The sky is blue, but the sky isn't a thing you can touch or hold or eat. Water appears blue but is actually colorless. Berries and flowers come in red, yellow, and orange far more often than blue. Animals rarely produce true blue pigment. There was very little in early human environments that required a separate word for blue, because there was very little to point at and say that specific thing. Red, by contrast, is everywhere that matters. Blood, ripe fruit, fire, infected wounds.
Danger.
Things that urgently need to be distinguished from the background. The brain pays attention to what survival makes important, and for most of human prehistory, blue was scenery. The second idea is that we genuinely perceive colors differently depending on whether we have words for them. This is the part that gets strange. A researcher named Jules Davy conducted an experiment in 2006 with the Piraha people of the Amazon, a group with an extremely limited color vocabulary. He found that without names for colors, people struggled to distinguish between shades that fell near the boundary of named categories. Their eyes worked fine. Their visual systems were fully intact. But without a word to anchor the distinction itself was harder to hold in the mind. A more famous experiment looked at the Himba people of Namibia. Researchers showed them a circle of 12 color squares, 11 green and 1 slightly different green. Himba speakers, who have rich vocabulary for different kinds of green but no word for blue, could immediately spot the odd square out. When the same researchers replaced the odd square with one that was blue, surrounded by green squares, Himba speakers took much longer to notice it. Some struggled entirely. Their eyes could see blue. The photoreceptors in their retinas were registering the wavelength. But their brains weren't filing it as a separate category. It was just another shade in the general visual field, unremarkable, unnamed, not worth isolating. English speakers had the opposite experience. They could spot the blue square instantly. They struggled with the subtly different green. Our categories shape what we notice. The words we have draw the lines on reality. This is a version of something called the Sapir-Whorf hypothesis, the idea that language influences perception. In its strong form, the idea that language determines what you can think at all, most linguists now consider it too extreme. But in its weaker form, the idea that language influences what you habitually notice and quickly categorize, the evidence is genuinely interesting. So here is what seems to have happened. For most of human history, the sky was blue every day. Everyone could see it, but it was background, constant, unnamed. The things that needed names were the things that changed. Red fruit ripening, green plants dying, yellow flowers blooming. The sky stayed the same every day, and what stays the same tends to fade into the background of attention. Then humans started making things. And here's where the story takes a sharp turn. The first known blue pigment made by humans appears in ancient Egypt, around 2600 BCE. Egyptian blue, a compound made from heating limestone, sand, and copper minerals together, was an extraordinary achievement of early chemistry. And crucially, it was expensive. It had to be manufactured. It required specific raw materials and knowledge. Because it was expensive and manufactured, it was used to make objects. Jewelry, pottery, paint for the walls of temples. Suddenly there were things in the world that were blue and also portable and important and worth describing. When you can point at an object and say the color of that thing, you start to need a name. Egypt developed one of the earliest words for blue. Then trade spread Egyptian blue and the concept of it around the Mediterranean. Other cultures developed their own words. The Romans had Carolinus. The Arabic world had Azraq. Languages that had managed without a blue word for thousands of years began acquiring one, in most cases right around the time that trade brought blue objects into their economies. The ancient Greeks eventually got one too, kyanos, from which we get the word cyan. But it came late. Homer never had it. Now here is the part that should sit with you. The researchers who study color perception across cultures consistently note that once a language acquires a color word, speakers of that language immediately begin perceiving the color as distinct. Children who grow up with the word blue sort colors differently than children who grow up without it. It happens fast. Within a generation, the way an entire community sees the sky can change. Your brain right now is doing something remarkable. It's looking at the world and sorting it into categories, and many of those categories were handed to you by the language you grew up speaking. You didn't choose them. You didn't consciously construct them. They were already there, built into the vocabulary, and your visual system adopted them so completely that blue just feels obvious to you. Self-evident. It feels like the sky is blue the way the sky just is blue, an objective fact about the world. But ancient Greek eyes were looking at the same sky, the same photons, the same wavelengths bouncing off the same particles of atmosphere. And their brains, running on different software, filed it differently. Not as a thing, as background. There is a researcher named Guy Deutscher who wrote a book called Through the Language Glass, one of the most readable explorations of how language shapes perception. He ran an informal experiment with his daughter, raising her without ever using the word for sky color, to see if she would spontaneously generate a word for it. She didn't. She struggled to describe it for a long time. Eventually she settled on white. Not because she couldn't see the sky, but because the sky is simply always there, and always the same, and without a word to make it notable, it was hard to notice. So what does this mean for you? It means the world you see is partly a product of the words you have for it. Not entirely. Not in the strong, deterministic way that language zealots sometimes claim. But partly. The categories you were given draw invisible lines across your visual field, making some things pop out as distinct and letting others blur into background. And it means that right now, there are almost certainly things you are not seeing. Not because your eyes are failing, Because you don't have a word for them yet. Distinctions your language hasn't given you. Shades of experience that exist in the world but that your brain files as background because nothing in your vocabulary has told it to pay attention. The Himba see differences in green that you cannot easily isolate. The Japanese language has separate words for light blue and dark blue in a way that makes speakers more reliably distinguish between them.